Hello everyone, we are Group 6, and this section is about the NMR principle. NMR is short for Nuclear Magnetic Resonance. NMR spectroscopy is a powerful tool for identifying nucleus based on the interaction of the electromagnetic field for a sample. The technique has developed in 1940s and soon become one of the most important methods of spectral identification in chemistry, biochemistry, and medicine. This short video is about the nuclear spin. In some atoms, the nuclei does possess an overall spin I. Quantum mechanics told us that a nucleus of spin I will have 2I plus 1 possible orientations. A nucleus with spin 1/2 will have 2 possible orientations. In the absence of an external magnetic field, these orientations are of equal energy. If a magnetic field is applied, then the energy levels split. Each level is given a magnetic quantum number m, which the nucleus is in a magnetic field. The initial population of the energy level are determined by the thermodynamics, which is described by the Boltzmann distribution. The lower energy level will contain slightly more nucleus than the higher level. It is possible to excite this nucleus into a higher level by using the electromagnetic radiation. The frequency of the radiation needed is determined by the difference in energy between the energy levels. The nucleus has a positive charge and is spinning. This generates a small magnetic field. The nucleus therefore possesses a magnetic momentum mu, which is proportional to its spin I. The constant gamma is always called the magnetogalactic ratio and is fundamental nuclear constant, which has a different value for every nucleus, and h is the Planck constant. The energy of a particular energy level is given by E equals minus gamma h over 2 pi times mb, where b is the strength of the magnetic field at the nucleus. The difference in energy between the levels can be found from delta E equals gamma hb over 2 pi. This means that if the magnetic field B is increased, so is delta E. It also means that if a nucleus has a relatively large magnetogalactic ratio, then delta E is correspondingly large. This is a basic arrangement of an NMR spectrometer. The sample is positioned in the magnetic field and excited where positioned in the radio frequency input circuit. The realignment magnetic field induces a radio signal in the output circuit, which is used to generate the output signal. Fourier analysis of the complex output produces the actual spectrum. The pulse is repeated as many times as necessary to allow the signal to be identified by the background noise. The magnetic field at the nucleus is not equal to the applied magnetic field. Electrons around the nucleus shield it from the applied field. The difference between the applied magnetic field and the field at nucleus is termed as the nuclear shielding. Chemical shift is defined as nuclear shielding. Chemical shift is a function of the nucleus and its environment. It is measured relative to the reference compound. For NMR, the reference is tetramethyl silane, SiCH3 4. For s electron in a molecule, their spherical symmetry and circuit in the applied field produce a magnetic field which opposite the applied field. This means that the applied field strength must be increased for a nucleus to absorb its transitional frequency. This upfield shift is always termed as diamagnetic shift. Electrons in p orbitals have no spherical symmetry. They produce comparatively large magnetic field at the nucleus, which give a low field shift. This shielding is termed as paramagnetic shift.